In 1931, a German engineer strapped a propeller to a train and broke a speed record that stood for over 20 years. In Scotland, an inventor built a flying monorail that could outrun every train alive today. In France, a quiet genius built a steam engine so efficient the railway buried his designs out of fear. These weren't crude old machines. They were engineering miracles decades ahead of their time, and we threw them in the scrap heap. Here are 10 forgotten locomotives smarter than anything on rails now. Number 1. The Schienen Zeppelin. Picture this. June 21, 1931. Between the towns of Karstedt and Dergentin in northern Germany, a silver bullet hurtles down the railway line at 230.2 kilometers per hour. That's 143 miles per hour. There's no diesel engine, no electrified overhead wire, no steam, just a 4-blade wooden propeller spinning at the back, pushing the train through the air like an airplane on wheels. This was the Schienen Zeppelin, the rail Zeppelin, and it set a world railway speed record that would stand unbroken for more than 20 years until the French CC 7100 electric locomotive finally beat it in 1954. Built in 1930 at the Hanover Leinhausen Works by German aircraft engineer Franz Kruckenberg, the Schienen Zeppelin looked like someone had taken an airship and bolted it to railway tracks. The body was made of aluminum to save weight. The interior was minimal, Bauhaus design. The whole machine weighed just 20.3 tons and could carry 40 passengers. It used a BMW airplane engine driving that rear propeller. Here's what makes this story tragic. The aerodynamic streamlining, the lightweight aluminum construction, and the obsession with reducing air resistance, all the things modern high-speed trains like the TGV, ACELA, and IC depend on today, were proven feasible by this single experimental machine in 1931. The Schienen Zeppelin was modified several times. In 1932, it received a new front bogie and switched to hydraulic drive. In 1934, it was fitted with a Maybach diesel engine and sold to the Deutsche Reichsbahn. But authorities worried about the dangers of an open spinning propeller in crowded stations. They also worried that on steep grades the propeller was useless because it couldn't push the train uphill effectively. The competition between Kruckenberg's own Flugbahn-Gesellschaft company and the Deutsche Reichsbahn's separate efforts to build their own streamlined flying trains further crippled the project. The Schienen Zeppelin was scrapped in 1939. One of the most aerodynamically advanced trains ever built was cut up for World War II materials before it could change everything. Kruckenberg himself went on to develop the SVT 137-155, a 3-car diesel hydraulic multiple unit that set another speed record of 215 kilometers per hour in June 1939. But the wartime collapse erased that promise too. Number 2. The Bennie Railplane. While Germany was strapping propellers to trains on the ground, a Scottish inventor named George Bennie was doing something even more radical. He was hanging them from the sky. George Bennie, born near Glasgow in 1891, drew up the first schematics for his railplane in 1921 and patented the design in 1923. His idea was bold beyond belief. Build elevated tracks 15 to 20 feet above existing railway lines. Suspend streamlined passenger cars from a single overhead rail. Power them with propellers at each end, driven by electric motors. Use the existing ground tracks for slow, heavy freight. In 1929 and 1930, Bennie built a 426-foot test track at Milngavie on the outskirts of Glasgow. The car was constructed by William Beardmore and Company, the same firm that built the R-34 airship. On July 8, 1930, dignitaries and reporters were invited to ride the demonstration train. Witnesses described it as operating with perfect smoothness, a sheer delight. Bennie claimed the railplane could reach 120 miles per hour. He calculated it could connect Glasgow and Edinburgh in just 20 minutes. To put that in context, even today in 2026, ScotRail trains between those two cities take roughly 50 minutes. A modern Caledonian sleeper service can't match what Bennie promised in 1930, but railway companies hated the concept. It threatened their entire business model. Bennie traveled the world seeking financial backing, including proposals for lines in France, Iraq, and between Blackpool and Southport in England. He even formed two new companies after his initial bankruptcy: the George Bennie Airspeed Railway Limited in 1946 and the George Bennie Airspeed Railway Iraq Limited in 1951, with proposals for combined passenger lines and desert irrigation systems linking the River Nile to the Dead Sea and another connecting Baghdad to Damascus. None succeeded. He was declared bankrupt in 1937 after financing most of the original development himself. His prototype rusted in a field for over 2 decades until it was sold for scrap in 1956. Bennie himself died in 1957, penniless. The world's first suspended propeller monorail was simply too far ahead of its time. Today, a blue commemorative plaque marks the spot in Milngavie where his test track once stood. Number 3. The PRR S1. In January 1939, the Pennsylvania Railroad rolled out something that defied imagination. The S1 class steam locomotive, nicknamed the Big Engine, was completed at the Altoona shops at a cost of $669,780, equivalent to over $11 million today. This was the longest and heaviest rigid-frame reciprocating steam locomotive ever built, period. At 140 feet 2.5 inches in length, locomotive and tender combined, it dwarfed everything else. It weighed 608,170 pounds. And it had the only 6/4/4 6-wheel arrangement ever applied to a steam locomotive, a 6-wheel leading truck, 2 pairs of 4 driving wheels each powered by their own cylinder set, and a 6-wheel trailing truck. This was a duplex design, meaning 2 separate cylinder sets on a rigid frame, sharing the work without the complications of articulation. Industrial designer Raymond Loewy, the same man behind the Coca-Cola bottle and the Air Force One livery, designed its Art Deco streamlined shell. The S1 went on display at the 1939 New York World's Fair under the lettering American Railroads, where visitors could watch its drive wheels spin under its own steam power on rollers. Now here's the part that gets fascinating. In regular service, the S1 routinely topped 100 miles per hour. On one documented test run with 12 loaded cars, Assistant Road Foreman Charlie Wapps saw the speedometer needle pegged at the 110 mil/Payot maximum. He timed the train with a stopwatch between Waneta and Hanna, Indiana, covering 6.3 miles in 170 seconds. That works out to 133.4 miles per hour. Other unconfirmed reports claimed the S1 exceeded 140 mil/Payot miles multiple times, and one alleged 156 mil/Payot dash between Fort Wayne and Chicago reportedly resulted in PRR being fined for exceeding the 80 mil/Payot track speed limit. The officially ratified world steam speed record is 125.88 mph, set by Britain's LNR Mallard on July 3, 1938. If the S1's claims had ever been officially measured, history would read very differently. But the S1's massive rigid frame couldn't navigate most of PRR's tight curves, restricting it to the Chicago to Crestline route. It was scrapped in 1949. Number 4. The PRR T1 Duplex. Pennsylvania Railroad learned from the S1 and built 52 of its successor, the T1, between 1942 and 1946. 25 came from the PRR's Altoona shops and 27 from Baldwin Locomotive Works in Philadelphia. The T1 used a 4/4/4/4 duplex arrangement designed by Baldwin's chief engineer Ralph P. Johnson with another stunning Raymond Loewy streamlined shell. The T1 was rated at 6,665 horsepower at 85 hub and produced almost 65,000 pounds of tractive effort. Its giant 80-inch driving wheels at 100 pub-length were spinning at 420 RPM, 7 full rotations every second. It used Franklin poppet valves rated for sustained 100 pub-length PRR operation. Then something remarkable happened. Franklin Railway Supply, which made the valves, started getting reports of cracked components. They sent an investigator out to ride T1 pulled trains. What he found shocked them. PRR engineers, running late, were routinely pushing T1s past 120 miles per hour. Former Smithsonian Transportation Curator William Whitham reported a credible anecdote of a T1 reaching 140 mph. If true, that would have made the T1 the fastest steam locomotive in history by a wide margin, beating Mallard's 126 mph record. But no T1 ever made an official record attempt. PRR was already buying diesels. By the late 1950s, every single T1 had been scrapped. Not one was preserved. Today, an organization called the PRR T1 Steam Locomotive Trust is building a brand new T1 from blueprints, locomotive number 5550, with the stated goal of finally settling whether the T1 could break the official world steam speed record. The lost knowledge of these machines was so complete that engineers are essentially having to reinvent them from scratch. Number 5. Chapelon's SNCF 240P. If there is one name in steam locomotive engineering that should be more famous than it is, it's André Chapelon. Born in 1892 and trained at École Centrale Paris, Chapelon brought something almost no other locomotive engineer brought to the field: rigorous scientific method. Before Chapelon, locomotive design was largely trial and error. Engineers copied designs that had worked before and made educated guesses. Chapelon used thermodynamic analysis. He used gas flow theory. He used high-speed stroboscopic photography to actually watch steam moving through valve gear in real time. The results were staggering. His SNCF 240P class, rebuilt and refined in the 1930s and 1940s, achieved a thermal efficiency that exceeded 12%. For steam locomotives, where typical efficiency hovered around 6 to 8%, that was extraordinary. By some assessments, the 240P was the most thermally efficient steam locomotive in the world at its time and was considered roughly equal in efficiency to early diesel locomotives of the era. His 1946 design, the 242A1, was a 484 capable of producing a continuous output of around 5,500 horsepower. It had the highest power-to-weight ratio of any steam locomotive in the world. Here's the dark twist. Chapelon's designs were so efficient that French railway bureaucrats worried he was making steam locomotives that competed with the electric trains they wanted to modernize toward. Despite his abilities, Chapelon was never allowed to design an entirely new locomotive class for mass production. Most of his masterpieces were rebuilds of existing engines. His protégé, Argentine engineer Livio Dante Porta, continued Chapelon's work, refining steam locomotive science for decades afterward. Chapelon's first major invention was the famous Keilchap exhaust, co-developed with Finnish engineer Kyösti Kilele. The very same exhaust system later fitted to Mallard for its record-breaking run. His other innovations included widening steam passages for better flow, increasing superheat temperatures from 300 to 400 degrees Celsius, using poppet valves to maximize efficiency, and adding Nicholson thermic siphons to fireboxes. In 1938, just before World War II broke out, Chapelon published his masterwork La Locomotive à Vapeur, outlining his methods. His prototypes were scrapped after the war. His knowledge fed forward into French TGV high-speed train development, where his studies of wheel-rail interaction at speed proved invaluable. But his own work in steam was buried by politics. Almost none of his original locomotive designs survived into preservation. Number 6. The South African Class 25 Condenser. Crossing huge stretches of the Karoo and the deserts of southwest Africa, where water was scarce and sometimes hundreds of miles between sources, South African railways needed steam locomotives that didn't drink like normal steam locomotives drank. The result, designed in cooperation with German firm Henschel of Kassel and built between 1953 and 1955, was the ASAR Class 25. 90 of these 484 Northern-type locomotives were built. 89 came from the North British Locomotive Company in Scotland, and one from Henschel itself. Here's where it gets clever. Instead of blowing exhaust steam out the chimney like every other steam locomotive in history, the Class 25's exhaust was recycled. Steam from the cylinders first passed through a small turbine that drove a blower in the smoke box, replacing the normal blast pipe draft. Then the exhaust traveled through a 16-inch flexible pipe along the boiler side to the massive tender. There, another turbine drove 5 sets of roof-mounted air fans through flexible shafts. The tender sides contained rows of condenser units, similar to automotive radiators. Air drawn by the fans cooled the steam back into water, which was then reused. The system was extraordinary. Trial results showed water savings between 88 and 93%. Coal consumption dropped by 10 to 15% because the recycled feed water entered the boiler already hot. A Class 25 could run between 400 and 680 miles between water refills, with claims of up to 800 kilometers. Because the steam wasn't expelled up the chimney, these locomotives sounded eerily different from any other steam engine. No sharp bark, just a low whoosh from the turbine fans. Between 1973 and 1980, all but 3 of the 90 condensers were converted to standard non-condensing locomotives, partly due to maintenance complexity and partly because electric and diesel traction was taking over those routes. The water recycling marvel was largely undone. In an era when we worry about water consumption and efficiency, the Class 25's 90% water savings looks visionary. Number 7. The SR Leader Class. In 1946, British engineer Oliver Bulleid was tasked by Southern Railway with replacing aging M7 class tank engines. What he produced was unlike anything steam railways had ever seen, a locomotive that looked like a diesel from the outside. The Leader class was an experimental 0660T articulated steam locomotive. It had a streamlined diesel-shaped body. It had cabs at both ends, allowing the driver to work from either end without turning the locomotive. It had thermic siphons for improved heat transfer. It rode on 2 powered bogies like a modern diesel. Its body sides were welded steel panels. It even used Bulleid Firth brown wheels, which abandoned traditional spokes entirely for a stronger, lighter design. The intent was revolutionary. Bulleid wanted to demonstrate that steam could match diesel and electric locomotives for labor-saving operation. No more turning engines. Greater distance between fuel and water stops. Easier maintenance. 5 Leader locomotives were started. Only one, number 36001, was completed. Trials around Brighton from 1949 onward revealed serious problems. The fireman's central compartment, sandwiched between 2 roaring fireboxes, reached intolerable temperatures. It was cramped with only 1 door and 1 window. The rail union ASLF rightly pointed out the fireman had no escape route in case of fire. The driver's cab ahead of the smoke box also became unbearably hot. Crank axles failed repeatedly under stress. Coal consumption was excessive. After spiraling development costs, indifferent performance reports, and political pressure from a railway industry pivoting hard to diesel and electric, the entire Leader project was cancelled. All 5 locomotives, completed or otherwise, were scrapped by 1951. Bulleid himself later moved to Ireland and attempted a successor design known as Leader Mk2, a turf-burning locomotive for the Irish Railways meant to use Ireland's plentiful peat fuel rather than imported coal. That project also failed. Modern steam advocates still debate to this day whether, with more development time and oil firing instead of coal, the Leader could have been the breakthrough that kept steam viable. Bulleid's earlier innovations, chain-driven valve gear on his Light Pacific and Merchant Navy locomotives, his no-frills Q1 goods engines, his disc-style Bulleid Firth brown wheels, all showed an engineer pushing boundaries. The Leader was meant to be his magnum opus. Instead, the most futuristic steam locomotive Britain ever attempted was erased almost without a trace. Number 8. The Crocodile locomotive. Most modern electric locomotives use traction motors mounted directly on the wheel axles. Smart, compact, efficient. But in 1919, that wasn't possible. Electric motors strong enough for heavy mountain freight were too big and heavy to mount low. The Swiss solution was the Crocodile. Officially designated the SBB C682 and C683, these articulated electric locomotives were built between 1919 and 1927 to haul heavy freight trains over the brutal grades of the Gotthard line from Lucerne to Chiasso through the famous Gotthard Tunnel. 33 C682 locomotives were built, plus 18 of the improved C683, for a total of 51. The design was brilliant. Each Crocodile had 2 long power units, called noses, at each end, holding the big body-mounted motors. The motors drove a jackshaft between the drive axles, which then drove the wheels through traditional side rods. Between the 2 noses sat a pivoting central section housing the cabs, pantographs, and the heavy transformer. The whole machine was articulated, hinging at 2 points between the noses and the central body. This gave the Crocodile incredible advantages. The articulation let it negotiate sharp alpine curves without flange wear. The body-mounted motors could be as large as needed without breaking axle weight limits. The driver sat in the central cab with excellent visibility down the long noses and was safely far back from any collision. The articulated configuration maximized adhesion under heavy loads on steep grades. The Crocodiles became legends. They were among the first large-scale applications of single-phase AC electrification. Eventually, with regenerative braking, they could feed energy back into the catenary while descending mountains. They worked the Gotthard line for over 60 years, finally retiring in 1982. Today's Swiss freight locomotives are vastly more powerful, but they still face the same mountain. The Crocodile solved it with a graceful design solution we abandoned for purely technical reasons. Several are preserved as historic vehicles by SBB Historic. Number 9. The Mallard A4. On July 3, 1938, on a stretch of track called Stoke Bank, just south of Grantham in England, a streamlined blue locomotive accelerated down a 1 in 200 gradient, hauling 6 coaches and a dynamometer car, weighing about 240 tons, with driver Joe Duddington at the controls and fireman Thomas Bray feeding the firebox. Mallard A4 class number 4468. Mallard hit 126 miles per hour over a quarter-mile stretch. That speed, set 88 years ago, is still the official world speed record for a steam locomotive in 2026. Nothing has ever beaten it. Mallard was designed by Sir Nigel Gresley, Chief Mechanical Engineer of the London and North Eastern Railway. The A4 class was introduced in 1935 and consisted of 35 locomotives. The streamlined wedge-shaped design wasn't just for show. Its shape was developed in a wind tunnel to cut air resistance and to create an updraft that lifted exhaust smoke away from the driver's line of sight. The A4s were the first British locomotives shaped by aerodynamic science. What made Mallard's record possible was a combination of careful engineering. The locomotive used a Kyle-Chap double exhaust system, co-invented by Chapelon, which dramatically improved steam flow. Mallard was the first A4 to enter service with this exhaust. The streamlined body slipped through the air. Gresley pushed his team to beat the recently set German record of 124.5 mph from 1936. The record cost them. Mallard's big end bearing on the middle cylinder overheated during the run, and the locomotive had to be removed from the train at Peterborough. But the dynamometer paper recorded that 126 mph speed clearly. Gresley had originally planned a follow-up attempt in September 1939, aiming for 130 mph. Then World War II broke out, and the record attempt stopped forever. Mallard ran in regular service until 1963 and is preserved today at the National Railway Museum in York. No steam locomotive has officially beaten her since 1938. Modern high-speed trains routinely cruise faster, but on the metric of pure steam-powered speed, Mallard is still the world record holder. Number 10. The M-497 Black Beetle. On July 23, 1966, on a stretch of track between Butler, Indiana and Stryker, Ohio, the New York Central Railroad set an American rail speed record that still stands 6 decades later. The train that did it wasn't sleek, it wasn't expensive. It was an old Bud Rail diesel car with 2 surplus jet engines bolted on top. This was the M-497, nicknamed the Black Beetle by the press. The project was conceived by Don Wetzel, Assistant Director of Technical Research for the New York Central. The goal was to gather data on the stresses of high-speed travel on conventional tracks without building any new infrastructure. The construction was almost laughably cheap. The base vehicle was an existing Budd RDC-3, originally built in 1953 for service to Mackinaw City, Michigan. 2 second-hand General Electric J4719 turbojet engines, originally used as takeoff boosters for the Convair B-36 Peacemaker intercontinental bomber, were purchased as military surplus for $5,000. The streamlined nose cowling was added by railroad workers. The whole project was completed at the Collinwood Technical Center in Cleveland in just 30 days on a total budget of approximately $35,000. The test results were stunning. On July 23, 1966, with a Beechcraft Model 18 flying ahead to make sure the track was clear, Wetzel piloted the Black Beetle eastward. He had been told to keep it around 180 mph. Approaching the speed trap near Bryan, Ohio, he glanced down and saw 196 mph on the dial. He reduced power. The official measurement at the speed trap was 183.68 mph, 295.6 km/h. That speed remains the fastest a train has ever traveled on conventional open track in the United States. No Acela, no diesel, no electric has touched it. If you enjoyed this trip through the road not taken, hit that subscribe button. Drop a comment telling us which of these 10 you wish had survived to change the world, and we'll see you next time on the rails.